Good morning, everyone, and welcome to the 2017 Royal Tyrrell Museum Speaker Series. Today, the Royal Tyrrell Museum and its Cooperating Society are pleased to welcome back a regular guest of the Speaker Series, Dr. Jon Noad. Jon is a petroleum geologist based in Calgary. Jon obtained his undergraduate degree from Imperial College in London, England. After working for a few years as a mining geologist in South Africa and as a marine geologist in the UK, Jon completed a master's degree in sedimentology with his thesis focusing on the fluvial sequence stratigraphy of Dinosaur Provincial Park. Upon completing his thesis, Jon returned to London University to pursue his PhD on the sedimentary evolution of eastern Borneo. After completing his PhD, Jon was lured by oil companies and, over the years, has worked on a variety of Middle Eastern and Canadian exploration projects. Through all of this, Jon has always been, and remains to this day, a real paleontology enthusiast. Today, Jon will review a great diversity of ichnofossils, traces left in the rocks by the movement of animals, from traces left by invertebrates all the way to traces left by dinosaurs. So without further delay, I present you Dr. Jon Noad.
Thanks, Francois. Well, thank you very much, everybody. Welcome to my talk. Today I'm going to be talking about trace fossils, and not just trace fossils, but also modern traces and how we can use those traces in the past. So, as Francois said, traces are structures produced in rocks and sediments by the processes of organisms. And there's all kinds of traces that you can see in the fossil record. But there are also the chance to look at these traces in the modern. And it's called neoichnology, which is a long word, but that basically means any kind of trace that an animal might leave behind. And you can use those modern traces to try and find them in the fossil record. So some of the traces that we might see and that I'm going to talk about today, the obvious ones are footprints, scratch marks, and perhaps resting traces where animals have rested or lain down in the past. There are also feeding traces, coprolites, so dinosaur poos, and gastroliths, which are inside animal stomachs, burrows on all scales, nests, and various other kind of fossils that we're going to look at today during the talk. And I have to warn you that after what I've told you today, you're going to find yourselves walking along, looking at the ground, looking at the rocks and finding all kinds of traces that you might not have seen before. And I just want to say about the photographs that they are from a huge variety of sources. A lot of them are mine, but they're from all over the place as well. So if anybody's interested about where one came from, please ask me. I haven't put all of the references on the slides just to keep them clean. So we're going to start off at the basis of this, what some people would consider the more boring trace fossils, but we're going to look at burrows first, and marine burrows in particular. And these are the kind of classic trace fossils that people imagine when they think about traces. And they're very useful for the geologists, particularly for the petroleum geologists, because these different kinds of burrows, and you can see there's all kinds here, from these kind of grape-like burrows here, to these cup-like burrows here, to these sort of skein-like burrows here. There's a whole variety of burrows, and a lot of these animals would only live in one particular environment. So if you see one of these burrows, you can say, well, there's a good chance we're in a shallow marine setting, open marine setting, or even a fluvial setting. So these are river settings. So these are very useful in terms of finding the different depositional environments. But for us today, they may be a little bit less interesting. However, not all of these are quite as boring as might meet the eye. And I'm taking you now to the deep water, some of the deep water trace fossils. And deep water traces are obviously made by animals that live at huge depths. And they have to live there's not a lot of organic material down there for them to eat. So they have to think about how they're going to do their feeding and how they're going to find enough organic material. And I've got a couple of examples here. So starting off with this guy up here, which is called a graptoglyphid, or a meandering trace fossil. So what's happening here is that there's an animal making this burrow on a bedding plane as it's trying to find its way through the sediment on an organic-rich layer and trying to cover as much ground as possible. Then we have this guy here. This is from actually the very boundary between the Cretaceous and the Paleocene, so around 65 million years old, from Italy. And this creature lived here, and it would kind of like make a spiral pattern as it went around trying to find as much food as possible. And then finally, and this is a very famous trace fossil called Paleodictian here, which is this hexagonal trace. And it kind of looks a little bit like a beehive. Now, these Paleodictyons, they were found in the fossil record, and nobody ever knew what kind of animal might have created them. And then eventually we started sending down these small remotely operated vehicles and then manned vehicles to try and see in the deep submarine to see what was going on down there. And they found modern versions of these trace fossils. So finally they'd seen that these things were not just in the fossil record, but that those animals were still alive today. But the sad thing was they couldn't find the creature itself that made them. So what we do know is that this little animal, whatever it is making these hexagonal sections and then taking bacteria and seeding the bacteria in each of these little hexagons. So it's basically farming the bacteria and then going in and culling them, presumably, and eating them. But we still don't know what active little animal is making those traces, even today, even though they're still around. Let's turn our attention to crabs now. So we're at a little bit bigger scale, crabs and lobsters. And crabs and lobsters are responsible for a huge variety of trace fossils. And this is a beautiful example from Libya. This is the field of view here is about 4 meters across, and these are very large shrimp burrows. And it's very nice to look at these burrows and say, well, they make a nice complicated pattern. But one of the interesting things about them, and if you look at some of these bulges here, is that when you have a burrow that intersects another burrow, you get a bulge. And people wondered why were these bulges there. And when they looked in detail, they realized that that was the turning around spots. So if a lobster or a shrimp was moving along its burrow and then it wanted to go off at a kind of angle, it would turn itself around, and their tails actually scratched against the side of the burrow. So you could see the tail marks where these creatures were turning around. So it's just a nice example of kind of real behavior, a bit like humans would do if they were turning around in a burrow. These are some other burrows here where this is from crabs that are actually making their burrow, and they actually flick out the pellets from their burrow onto the sandy sediment here. And this creature here is another burrow that you may well see if you ever look at building stone that comes from Manitoba. This is from a building stone called, it's from the Ordovician from Manitoba. And then it's actually Tyndall stone is the name of this one. And then this is the guy that you might not want to invite to your house. This is a burrow from a small shrimp, a glass shrimp, and the burrow is called Ophiomorpha. And Ophiomorpha, what happens here, you can see it's got a kind of pelleted surround. And what this charming little glass shrimp does is it takes its own fecal matter, makes it into a ball, and then sticks it on the side of its burrow. So if you can imagine, it's basically this creature is using its own poo as wallpaper. So I'm not sure I would want to invite a glass shrimp round to my house. Okay. Another interesting factor when you look at burrows is the size of burrows. And what tends to happen is that if you have very brackish conditions, so if it's a kind of mixture of salty and fresh water, then the animals get pretty stressed and they don't grow quite as large. So it's a bit like if you have a lot of animals herded together, they tend not to be as large. However, there are situations where normal burrows, so normal U-shaped burrow that we can see here, there's these U-shapes here, the normal size would be about half the length of this pencil. But these guys are absolutely giant. And the reason for this is that they were found in sediments where you had a lot of these channels. And these are tidal channels, so you get these very strong tidal currents moving in and out of these tidal channels. And all of the small animals are being washed out and washed away. And the only worms that have managed to hold themselves in place on the seabed when they're moving around in their burrows and at the surface of their burrows are the really big guys. So you're actually singling out just the really big organisms here, and you can see that by the size of these burrows. I'm going to turn it now to looking at a bivalve. So this is a guy that looks like this. This is a Unionid bivalve, and these photos actually come from Dinosaur Provincial Park, so not that far away from where we are now. And I've got a sad story to tell you about these, but it's a story that's picked out by the beautiful trace fossils that we see. So we imagined about 75 million years ago, we have a gently meandering river, and in that meandering river are living these beautiful freshwater bivalves, and they are just loving it. So you can see there's lots and lots of them, and these traces here were made by, they're the dwelling traces. So in kind of technical terms, they call them domicnia, like where their domicile is, where these guys were living. So all of the Unionid bivalves were living on this riverbed. Anyway, one day, a huge flood came through this area, and we're talking something probably like a 1,000-year flood, and it deposited about 30 centimeters of sediment on top of these guys. So that surface there is down here, And then all of this sediment was deposited by the flood. So all of the Unionids, instead of living where they're supposed to, on the riverbed, were all buried. So they all climbed out. And if you look carefully here, you can see these kind of cup-shaped marks here as all of these bivalves were making their way up to the river surface. And these are called fugicnia. It's like a fugitive because they're escape structures. So these Unionids were escaping from where they were buried up to the riverbed. So they all got up to the riverbed, started feeding again, started moving around, and then disaster struck. And at the end of the flood, the water level fell again, and all of these Unionids were left on this dry riverbed. And they do very well when they're underwater, but they don't do very well when they're exposed. And all of them basically just went and just butterflied open. And this is not a very brilliant example, but you can see that all of this shell material here was where these guys ended up dying because they were exposed on this with no water covering them up. So we can tell all of that story from the trace fossils that are there. Let's move on to talk about insects and a few more arthropods now. This trace here, this is a picture by a very expert freshwater and terrestrial trace fossil expert, Steve Hasiotis. And this shows some kind of midge or bug, like a daddy longlegs, flying across the sediment and kind of like getting his legs caught, or her legs caught, and dragging the legs along in the sediment here while it was doing these kind of like death spirals to try and escape from getting caught up in the sediment. So there's lots and lots of different types of insects, obviously. Insects are far more varied than most of the other life types on Earth. And we're going to start off by looking at some that bore into wood. And if you go on eBay and you look at the petrified wood that's on eBay, every now and again you'll find an example like this. So this is a sliced through petrified wood from Arizona, and you can see there's this beautiful trace burrow in there. So quite often the people who've sliced these open don't realize. So you can pick up a nice example of this petrified wood for no more than you would pay for a normal piece of petrified wood. And yet it might have a whole series of burrows in it like this. So this is a nice example of insect activity. And more normally, your insect activity might look a bit more like this or like this. So what's happened here is that you've either had insects or you've had shallow marine bivalves again, these like a little bit like scallops, that are boring down into the wood or boring down into the sediment and leaving these trails. And this one here, this very nice example here, is actually from Drumheller. So I had a nice trace fossil example that came from right here, just a little bit further along, going west from here towards East Cooley, east from here towards East Cooley. There are also this is a modern example here to show you what some of these burrows look like. And then here I've also put in some examples from what are called shipworms. And these shipworms were actually boring bivalves, not boring as in the not very interesting sense, but boring as in they bored into wood. And these guys would bore their way into the wood and feed on the wood. And so this actually led to copper-covered hulls on vessels, because the wooden vessels that used to sail around, the T-clippers, they were all being attacked by these bivalves, and they were basically drilling holes in the hull. And these holes all had to be caulked up. So eventually somebody realized that they could get around this by covering the hulls with copper. More insect traces here, and what I'm talking about here is that quite a common trace fossil is root traces. And root traces, this is a root trace here where we have a plant that's growing down in tidal flat sediments, and you can see it has these charcoal-lined burrows. These roots here are from eastern Alberta, from Sandy Point, but there are also creatures which create burrows that look very much like root traces, but they're actually made by tiger beetles. And so if you look at this example over here, we've got these very straight vertical burrows making their way down through the sediment. And this is a modern tiger beetle burrow sitting down here. So these tiger beetles will drill down into the sediment, and then they'll live down there. While the larvae will live down there, and eventually they'll make their way back up and become beetles. And how do you tell these apart from the roots? Well, they're much straighter, and they don't have this charcoal lining. And then I put in a few other burrows here as well. So the common belief amongst geologists is that, generally speaking, river deposits don't have a lot of trace fossils. And we've already seen those ones from the Unionid bivalves, but there are lots of other traces in here as well. And you might be able to pick out here that there's some nice, what are called meniscate burrows, where these guys have been pushing the material back into their burrows as they've been working their way through the sediment. I put this in. I have a fossil example of a termite nest to show you. This is from the Jurassic. This is a Jurassic termite nest that's about 5 feet tall that's been exposed as a result of erosion after these sediments have been deposited. So we've got a fossil termite nest here. But a couple of years ago, somebody found a termite nest that had been abandoned in Brazil. And they thought, what would happen if we pour concrete into this termite nest? So we simulate that it's being fossilized. And then after concrete is set, we'll go down there and we'll excavate it. So they poured over 10 tons of concrete into this termite nest. And this is what happened when they started excavating it. And there's a beautiful video on YouTube that if you just do a search on Brazil termite excavate or something like that, you'll find the whole video of them excavating here. So you can see this area here is about probably 20 to 30 square meters. But some of these side tunnels here are going off for maybe another 50 meters in each direction. So this is something that you could also expect to find in the fossil record. And my question to you guys is, do you think you would necessarily recognize that you had a termite burrow if you just saw these big balls here? These balls are the nests where those would be the egg-laying chambers that the termites were making, where they'd leave the eggs to hatch. So this would be the connecting burrows that would go between these. So I think it's something that really we should be looking out for in the fossil record, because something like this, obviously, you can see that there's a big structure here, but would you recognize these in the fossil record? And there was actually a case the other day where someone posted on a geological website and said, what do you think these balls are from a marginal marine setting? And I wrote back and said, well, have you thought about maybe they're termites? Because certainly they could be preserved in the fossil record. Termites are also responsible for what are called fairy circles, and this is an example from Namibia in southern Africa. We've got some zebras running across the plain here. It's a beautiful picture, not my picture, but beautiful picture. And it also shows these very striking circles here, which are called termite fairy circles, which is a lovely name. So what happens is that the termites eat away at grass roots, and they make the soil less dense, more porous, and they end up creating a kind of sandy donut hole. And so that sandy donut hole will then soak up more water, and then the plants start growing around the edge of it, and the termites continue eating their way out and pushing this plant material out to the sideways. So that's what a termite would look like. So they create these holes, and these have never been identified in the fossil record. And you wonder whether you see these kind of weird circular structures sometimes in the fossil record, and people are usually saying, well, I think that could be a concretion, that could be something to do with a cementation front, where minerals are creating a kind of, that they're actually cementing up the rock. But just as easily, it could be something like this to do with termites. And termites are one of the most prolific creatures on the planet, so every chance that they could be preserved in the fossil record. This is and some nice examples here of shrimp and lobster footprints. And this one here, this is from Banff, from the traffic circle in Banff, so just as you're entering Banff. And what's nice about this one is that we've got Mummy here. My daughter, I've taken my daughter to see this a couple of times. She's 5 years old, and she loves this idea, is that we have the mummy there, and if you look very carefully there, we have the baby next to it. So the mummy and the baby shrimp might have been walking along next to each other. This surface here is from Borneo, from the field area where I did my studies, and what we've got here is an absolute nest of mangrove lobster footprints. This is what the mangrove lobster looks like in the modern day. They're still around. These are Miocene in age, so around 50 million years old. And these are very, very useful because if you can imagine, this is a mangrove lobster, and when it dies, it will make a fossil. And it will probably shed its skin a couple of times, so it might make 5 fossils maximum in its life. But can you imagine how many footprints it will make in its life? Probably tens of thousands. So there's tens of thousands times more chance that their footprints will be preserved than the animal itself. So if you find these in outcrop or even in core, then that gives you a great opportunity to say, well, I think we're in a fossil mangrove setting if you have this particular type of footprint. So the footprint is basically giving you an idea of a depositional setting. And I zoomed in on this one print here because this is a print showing a lobster with a limp. So here's one of his or her legs, on the sets of legs on one side, but on the other side, this animal clearly had a bit of a limp. So we can't just tell that there were animals walking through here. we can even tell about the health of the animal from the trace fossils. Okay, I'm going to move on to talk a little bit about fish now and fish fossils. And we're going to start off by looking at fish feeding activity. And this is one of those things where you really do need a little bit of an eye of faith. But once you start spotting fish feeding traces in the fossil record, you can see them everywhere. And this is an example from Borneo. So here we have an organic rich sediment, so a lot of possible feeding material in there. And you can suddenly see there's this weird kind of hole that's incised into it. And that hole I interpret as a ray feeding trace. And I base that on the fact that this is some modern rays here. And the way that rays feed, first of all, is that they'll use their nose to nose into the sediment, and they can actually, they can feel with their nose whether they think it's prospective for finding clams or other food in there. And they'll also use their fins as a wafting agent. So they'll, just like we would, if you drop something on the beach in the shallow water, then you'd kind of like waft with your hand to try and expose what was going on. And that's exactly what the rays are doing here. And some of these pictures I took in Chicago Aquarium, and just to show that what these guys are doing, and they were busy doing that waft with their fins. And then this example here, that is a ray tail in the middle there. You have to trust me on that one, because the ray itself is completely obscured because it's actually doing a particularly good wafting job. So this is an example from core, from the Cardium Formation. So this is drilled in Alberta, and this is what I'm interpreting as a possible sturgeon feeding trace. So the sturgeon, so it hasn't got the fins to do the wafting, but it has the nose to do the pushing into the sediment. And I think this guy's used its nose here to dig out this weird shaped little depression, which is then filled up with pebbly material. Now, I think the steepness of the sides here and the steepness of this exposure is what leads me to think that. But I know not everybody in this room is probably thinking, well, that's obviously a fish feeding trace. But I think the more you look for them, the more chance there is that you might find them. Fish are also capable of making burrows. And the lungfish, one of the reasons that the lungfish has lasted so long is that they're able to burrow into sediment and survive while the area that they're living in has dried out. And I've got some examples here. I'm afraid that these pictures are in black and white, but there's some really nice examples here of lungfish burrows. Now, how do you know that this is a lungfish burrow? This is one of those things, again, where people will be saying, yeah, sure, I can see a kind of bulbous bit of rock there, but how do you know? And the way you know is, sadly, because quite a lot of these examples have the lungfish inside. So they've used their tactic to bury themselves and to try and keep themselves safe, but sometimes that drying out period has just lasted too long and they've died in there. So we've got lots of examples of these burrows with the lungfish inside. So that's the smoking gun. The fossil is still there. So I've got some examples here from Zion National Park down in the States where you get these lungfish burrows on particular horizons. So what the lungfish burrows are doing is they're picking out climatic times when the climate dried out. And so the ponds that they lived in would dry out. So you'll just see them on particular horizons. And in between, these are fossil sand dunes here. There's a little lake on the edge of the sand dune, and the lungfish burrows are picking out those periods of drying. This is another example here where, once again, you have to be pretty sharp-eyed to spot these burrows in the sediment. There's pencil there for scale to show the size. These ones are from Wales, but they're surprisingly common, these fish burrows, in shallow marine and marginal marine settings. Another nice fish trace fossil is fish fin marks. And probably the best known example is from the Green River Formation, and it's from a type of fish that's called Notogoneus. Once again, how do you know what kind of fish made these marks? Well, this particular trace, you can see that there's a whole variety of marks here. So you've got red marks in the middle, which are the feeding traces. So they kind of look like this, where the fish has just been browsing on the seabed. And then there's yellow marks, picked out in yellow here, these ones at the edge, which are its pectoral fins. You see those two fins at the side there, which are kind of dragging along in a nice sinuous pattern as the fish is swimming along. And then there's also a caudal fin. So it has the fin kind of on its belly that hangs down, and that fin is dragging on the bottom as well. So because this is the only type of fish that had that morphology, we're able to tie the fish fin marks to that particular fish. And that occurred in the deeper part of the Paleolake. So this was a bottom-dwelling fish. So it's also nice evidence that that fish was definitely a bottom dweller because it left those fin marks. But you also see fin marks where things have dried out. So this is an example here from the Karoo in South Africa, so around 240 million years ago. And here you have this, you can see these fin marks here. You can also see some marks here from some invertebrates that are walking on this very shallow river or pond. And what's happened here is that this is not a fish that likes living on the bottom. This is a fish that's forced into it because the pond is busy drying out. So the water depth is probably only about this much, and the fish is still trying to swim around. And before we leave fish, I just want to show you what I believe to be the world's most beautiful trace fossil. So around 10 years ago, they started identifying some very, very weird structures off the Japanese coastline. And this is what they look like. And they actually called them Japanese crop circles, because I don't know whether you guys remember from maybe 20, 30 years ago when these guys were faking up these crop circles, which you could kind of call a human trace fossil as well. But anyway, these are a marine version of that, a marine crop circle. And no one knew what they were. And eventually they left some cameras down on the seabed, and they sent divers down to live on the seabed for months at a time. Actually, I'm exaggerating. That didn't happen. But sooner or later, they actually found out that these structures were made by this little pufferfish. And the pufferfish is only about this long, but he spends 10 days carefully making this structure. He uses his body to create the peaks and troughs. He forms special little pattern in the middle there, and then he decorates all of the outside with bits of shell and coral, all in the hope that his woman will come and lay her eggs in the center. And she may not be satisfied, and they only last for probably a few days after he's made them. And if nothing's happened by then, he goes off and he makes a new one. And one of the nice things about this pufferfish is that when they found this, the pufferfish was a new species as well. So they got a new species and a beautiful trace fossil. And I would challenge any geologist, if you found this in the fossil record, would you be saying to yourself, oh, well, that's obviously a fish nest? Because really it's hard to tell. And we had a discussion over a few drinks, which is the best place to talk about wacky trace fossils, about other fish marks. So would you recognize a salmon nest or a trout nest if you saw it in the fossil record as well? So this is another thing that we should be looking out for in the fossil record after looking at what the ones in the recent look like. So let's move on to dinosaurs now. Always a favorite subject, and I think we're in the perfect place to talk about dinosaurs. And we're going to talk about not just footprints, but some of the other interesting trace fossils. And I put this example here. This is a skin impression trace of a dinosaur. So this is another trace fossil, and this is left by maybe where the dinosaur rested its elbow against a muddy bank or something like that. But anyway, it's left these very nice skin impressions. Probably the most famous dinosaur trace fossils are footprints, and I'm going to show you some kind of classic footprints in a minute, but there's also some footprints which tell you more about the dinosaur behavior, and I'm very keen on behavior, and I think it's nice to think more about not just, oh yes, a dinosaur was walking there, but a dinosaur was walking there in a funny way. So the first example I've got here is showing you a slip face. So this is the edge of a dune, and this is a modern example, but some kind of animal has walked its way up the edge of the dune. And you can find fossil examples of this, also from the Karoo in South Africa, where animals have been walking in these aeolian, these wind-blown desert conditions, and they've actually left their traces, which don't really look like footprints, but they tell you that this animal was just like a human being trying to walk along the edge of the dune, was kind of slipping sideways as it tried to make its way along. This example here is from the UK, from the Jurassic of the UK. And what I like about this is a sauropod footprint. So this is a long neck footprint, and that's this big footprint there. But what's cool about it is these scratches here, because these scratches are where the dinosaur has put his foot down, or her foot down, and the fingernails have scratched these grooves. So these are actually fossil fingernail scratch marks. How nice is that to think about that? Okay, the next example we have here is from the Karoo. So we're back in the Karoo in South Africa. And these are some nice footprints left by a large amphibian as he's walked, probably Bradysaurus, as he's walking across the same pond where those fish fin marks came from. But what happens when things get muddy? What happens when you've got your Wellington boots on and you walk across a nice muddy field? Well, your feet start growing in size. It's weird, but your feet get bigger and bigger because of all the mud that's sticking to them. And this is exactly what happened to this animal. So as I tracked his footprints across the outcrop, his footprints stopped looking like nice four-toed footprints and started looking like these small impact craters. And this is what I call a squelch print, because this squelchy amphibian is walking his way across this muddy sediment and leaving these very nice examples of behavior as opposed to just footprints themselves. And I just put this one in here. I'm not going to talk much about tooth and claws, but another way that you can see evidence of dinosaurs and dinosaur predation is where you see scratch marks from teeth and claws on other bones. And that's something that other people know a lot more about than I do. So this is just to show you some more footprints. We've looked at the good stuff. This is the good stuff in the middle here. Famous example from Colorado. And I have to say they do color them in with, they paint them with charcoal every month to make them stand out. So that coloration is not exactly normal. But you can see there's these beautiful trackways going in all directions here. And this is a great, if anyone ever wants to go and visit it, it's a place called Dinosaur Ridge just outside Denver. So that's the perfect. And then we've also got the kind of imperfect. So yeah, it's easy to see that these are dinosaur footprints. I think any of us would know that. But would you know that this was a dinosaur footprint sitting in here? This is from Alberta, from Sandy Point in Alberta. And once again, you might say, well, how do you know that, John? Well, one of the ways that you kind of get some evidence that this might be a dinosaur footprint is that there's a whole bed of these dinosaur footprints in here. So this layer here has lots of these kind of ironstone cemented concretions, which are actually dinosaur footprints. And then over here, there's a sandstone bed that it has a very kind of eroded top. And normally the sandstone beds have nice flat tops, but this one is all eroded. And I think this is evidence of dinoturbation, as they call it, perturbation formed by dinosaur footprints, or it's a trample zone. So this is a trample zone where dinosaurs have been walking across this sandy channel deposits, and they've just stirred up the sediment while they were walking across it. And I just put this one in because I thought I'd have one picture of my daughter, Arizona. Her middle name is Plessy for Plesiosaurus, so she was destined to be interested in dinosaurs from birth. And she is standing next to another example of one of these beautiful sauropod footprints. So that's a single footprint that's several times as big as my daughter's head, my dinosaur's head. Oops, what a bit of giveaway there. Okay, so what about other dinosaur trace fossils? Well, dinosaur nests, they've received a lot of attention over the last few years, especially with some beautiful examples that have been collected from China. In fact, the first dinosaur nests were recognized a long time ago in Mongolia when an expedition went through, I think in the 40s. And it was a guy who, I think he was a reporter who got out of the vehicle, and they're driving these beautiful old vehicles around in the Gobi Desert, and he went off for a smoke. We'll say he went off and hid behind a tree to have a smoke, something like that. And he found the first fossil dinosaur nesting sites. And since then, there have been a lot more found, and this is what the nesting sites look like, which are great. And it's very interesting because dinosaurs laid their eggs in different ways. So I'll embarrass myself here by doing a bit of dinosaur egg laying, so that there's certain females who kind of like do the circle and go around, and they lay their eggs in this nice concentric pattern. Some other dinosaur ladies would kind of like go backwards and forwards and lay their eggs in a kind of zigzag pattern. So there's different patterns in different types of nests. So that helps you to identify what kind of dinosaur made it, but also gives you a nice idea of what the dinosaur might have been doing in terms of its behavior. So this is to show you that's the perfect example with the eggs here. And this is the kind of imperfect example. This is what nests look like when they're not very well preserved. So this is what you should be looking for as a geologist, because you are less likely to find this one than you are to find something like this. Now, to go with the nests are these weird marks here. And you see these kind of like depressions. So this is close to a dinosaur nesting site. And these have been interpreted as scratch marks where you had this big male dinosaur kind of trying to impress the female and doing the arr, arr, and he's scraping with his foot on the ground to try and impress the female. And this is exactly what birds do today. The plover is a nice example. So the plover, well, we'll talk about more about plovers in a minute, but the plover does the same thing, also scratches the ground to try and impress the female with his scratching ability. Dinosaur and reptile burrows. Now, you remember when we talked about lungfish, I said the way that you know that it's a lungfish burrow is that you find lungfish, fossil lungfish, who have died in their burrows. And there was always talk about, were things like this burrows? And here it's pretty obviously a burrow, but what kind of creature might have been inside? So if you didn't have the creature inside, it was hard to know. And a few years ago, a guy called Anthony Martin, who's a fantastic dinosaur trace fossil guy, found these fossils here from Oryctodromeus. It's a small dinosaur, probably this kind of size dinosaur, and he found a mother and 2 juveniles in the bottom of one of these burrows. So this is what the fossil burrow looks like. Not that impressive, really, a kind of whitish fossil, but it's the fact that the dinosaurs were found inside it that shows that some of the dinosaurs were living in burrows. And we imagine them kind of walking around on the plain and being, very not scared of anything. But some of the dinosaurs, obviously these smaller ones, they were capable of digging out burrows and living in the burrows, which would help to protect them from predators. So I'm sure that there are many more burrows here in Alberta. I mean, we've got great dinosaur area, and I'm not sure that we've ever really confidently recognized dinosaur burrows. So I think it's something that when I go out in the field now, I'm always looking for the hope that I might recognize the dinosaur burrow. Most of what I thought of burrows that I found so far have turned out to be footprints, but I'm still looking. There are other reptile trace fossils as well, and I've just put in some nice examples here. So this is a sidewinder. So this is a kind of snake that instead of just slithering across in a straight line, it has this weird rolling motion. And what they believe is that the reason it does this is because the sand is so hot, is that it's trying to touch as little of the sand as possible. So this snake is actually, the snake's moving in that direction, but it's leaving these very challenging marks. And I think you'd have trouble knowing what those marks were. This is one that I saw in Oman when we were just driving along. We stopped the car, and the snake had gone, but the snake had this is pretty obviously a snake trace, in my opinion. These are alligator drag marks, tail drag marks here, as the alligator was going into a pond down in Florida. And then we've got these turtle tracks here as well, where the turtle has come ashore, probably to lay its eggs. And then I put this one in here because this is a not very brilliant photo, but a photo I took of a snake going into its burrow. And this is another thing that I haven't seen in the fossil record, but they must be there somewhere. Snake burrows must be there somewhere. And then I just put this one in of a lizard. And this is a lizard that we saw walking along. You can see that the lizard's feet are here. This is really nice trace fossil. The feet are here, and then his tail is here, dragging along in the middle. And at this point, the lizard saw us, and he had heart failure because we were out in the desert in Oman, and he just went, whew, and he was gone. So if you saw this in the fossil record, you'd be thinking, well, I've got this nice lizard trace fossil here, and what happens there? And you might not know that he was scared off by a potential predator. So this is another example where we can learn from the recent and take that into the fossil record. Okay, I'm going to talk about birds now. And I put this in. This is a reconstruction, but I found this bottle on the beach in Holland while I was walking along, and it had all these bird footprints by it. And I thought, what is going on? Why are there all these bird footprints by this bottle? And we walked a little bit further, and there was I didn't have a camera with me, which is such a shame. There was a bottle there, and there was a bird attacking its reflection in the bottle and fighting its reflection. And as it was doing it, it was leaving all these footmarks. So this is an example of a bird being a bit of a bird brain, but fighting itself in a bottle. So one of the things that I found while I was in Borneo, and probably the most exciting day of my whole PhD, was finding fossil bird footprints in these Miocene sediments. And this is an interpreted section here, where I've interpreted all of the footprints here. And these white dots here are prod marks, where the bird's prodded its beak in, interpreted prod marks. And then this just shows what the footprint would look like. And I've kind of highlighted it just to show you what it looks like. And because they don't have a hallux, so they don't have like a back claw, you've got these three-pronged toes here, which are pretty similar to a killdeer, which is a kind of plover. So they'd look something like this. This is the bird that did the deed. And there are probably plovers living in Drumheller. They're certainly in Calgary as well. So you can see modern examples of what I'm seeing in the fossil record. So that was very nice and great to see fossil bird footprints. But there were also these enigmatic traces. And I've got two examples of them. So this is not just a one-off. You see they're kind of sinuous trace, and they've got this kind of zigzag pattern to them. There's another one here as well. So what were these zigzag pattern traces? And I had a look at some zigzag fossils, and so this is an eating trace from a sawfly. These are from deep water sediments, a little bit like those meandering sediments we saw earlier. And this is another kind of small organism, but none of them were quite right. So I'm looking to try and find out what might have made these trace fossils. And I had a stroke of luck. I went on holiday to South Africa. I used to live in South Africa, so we went back for a holiday there, and I went out running. And when I went out running, I took my camera with me. And the first stroke of luck was that I came across 15 French maids, which was just awesome. I mean, I thought that's one of the days you look up to the heavens and you say, thank you, thank you, thank you. And they were actually filming a beer commercial, these ladies. So that was great. And in the background there, you can just see that there's a lagoon behind them. And finally, I dragged my attention away from these fascinating specimens to look at the lagoon. And there were these are called blacksmith plovers, but they're closely related to our killdeers and our other plovers. And they were on the beach, and what they were doing with their beaks while they were feeding was going like this with their beaks. So they were kind of like using their beaks as a kind of sieve to go through the sediment. And this is what the marks look like. So there you can see going backwards and forwards. So another one there as well, another one here as well. So they're not perfect zigzags that have been recorded, but these are my smoking gun. So thanks to the French maids, I was able to find what had made my mysterious trace fossil. I just put these hippo traces in as well, because while these ladies were here, there's a whole herd of hippos just behind them, and they were completely oblivious of them. They were too busy with their beer commercial. So that led me on to think about other bird traces, and so bird traces have never been reported from the fossil record beyond the prod marks. No other bird traces have been reported. So I would like us to start looking out for these. So this is an impact trace from a herring gull dropping a shell on the beach to break it. This is allegedly an ostrich trace, where the ostrich has literally put its head in the sand. This is a kite smashing open little gastropod shells, snail shells. This is just ducks on a riverbed poking around. These are turkey scratching. This is a raven that's actually dropping tortoises onto, this is also from South Africa, and it's dropping tortoises onto the ground to break their shells open. This is a woodpecker storing nuts. And then this is my favorite here, which I've saved till last, where there's a little rabbit hopping along here. And then this is 2 owl wing marks. So what do you think happened to that rabbit? So beautiful stuff here, and these have never been seen in the fossil record. So I'm hoping that we can look out for these guys, and I've called this new science Ornithocoenichnology, which is the study of bird feeding traces. There's also DLTs. Anyone know what a DLT is? It's a duck landing trace. And I have a whole series of duck landing traces which I've seen in Calgary, and I've taken photographs of them. This is a particularly nice one. This is kind of a little bit like our owl one, but this is a duck has landed, and then kind of like started waddling off. So there's a whole load of different kinds of traces that you can see in snow, and snow provides a perfect opportunity to explore traces and how they start off and what happens to them over time. This is a bird trace, but it's been kind of melting for a few days. So it's a very good way to study traces, including DLTs. So if you ever see a DLT in the future, you can think, that's a DLT. Jon told me. Okay, and the other science that I want to invent, because it doesn't exist, is the study of fossil bird nests. Because I had never seen a paper on fossil bird nests. This is the closest I came, which is where you have these rivers with a very high carbonate content, limestone content. And so the limestone, the Victorians used to put these things like birds' nests under little waterfalls there, and they would gradually get covered with tufa. So you'd end up with a fossilized bird nest deposit. So I'd love to see us find some more bird nests. So we found the fossil dinosaur nest, but we haven't found birds' nests in the fossil record. And there's a giant bald eagle nest sitting up here above my friend Mehran. This is from Grand Cache. So you would think you could see a 6-foot across eagle nest full of goat skeletons. Okay, so we're now going to finish off by talking about mammals, and this is an elephant footprint, and I once slept in an elephant footprint while I was on a field trip in Namibia, and I felt very cool. Oh, I slept in an elephant footprint. And somebody said to me, a guide said, That was a very stupid thing to do, because when elephants walk back through a place they've been before, they step in the same spot. So the one thing you shouldn't do, and this is something I hope you guys all take home with you today, is sleep in an elephant footprint, because they may be back. So there are a billion examples of different kind of mammal traces, and far too many for us to do anything more than just scratch the surface. And literally, some of them have scratched the surface. This is a beaver scratching the surface of a piece of wood with its teeth. This is a beaver drag mark, where these are the beaver footprints in the middle, and these scrapes here are where it's pulling a branch across to help to put in its set. I've got some examples of bobcat scat here. This is kangaroo traces here, which I didn't take this photo, but it's lovely to see them. And you can also get ones with tail marks in the middle where the kangaroo was dragging its tail. Some bear footprints, but there's so many footprints out there. And I want you guys, when you go on your next walk around Drumheller, either when there's snow on the ground or where there's mud on the ground, to keep an eye out, because there's such a variety of footprints. This is a very famous dinosaur track on the left-hand side here. This is called the Roland T. Bird Trackway. And Roland T. Bird was one of the people who collected for Marsh and Cope back when they were having the dinosaur wars. And he found these trackway sites in Texas, in Glen Rose in Texas. And what you've got is a plant eater here and a meat eater. And you can't really tell whether they walked at the same time, but it's nice to imagine the plant eater was walking and the meat eater was stalking, walking and stalking. And we've got a modern example here from the snow where we have something like maybe coyotes chasing a rabbit and the rabbit's going across. So this is something where you can actually start looking at the behavior of these animals by looking at their trackways as well. And I should just say, if you ever go to Glen Rose, don't miss the Creation Museum there, because it is a hoot. Okay, this is fun with squirrels, and the reason I put this in is because my daughter and I walk my daughters to school every morning, and we go past this park on the way, and we always look to see whether there's any squirrel marks there and tracks. And she's actually, if she sees the squirrel, she's running across to see what kind of track it made, because I brainwashed her, basically. And this is to show what fresh squirrel tracks look like, and this is what weathered squirrel tracks look like. So this is just 2 days later. So this shows that they soon degrade, and it's the same with footprints. This is some squirrel gnaw marks. This is just, I found this on the internet. But this thing here, you've got this little impact crater here and a kind of jump, and then a crater here, and then a jump, and then a crater here. And what this is a squirrel surf mark. And this is not a squirrel that's doing the surfing. This is great. I did a search on squirrel surfing, and I found this photograph on the internet. Who knew that happened? But anyway, what's happening here? We saw the squirrel doing this. And what the squirrel was doing was he was jumping, or she was jumping, and then kind of just surfing on their tummy. Because this is further than a squirrel could jump normally. You can see the trackways here are really quite close together. They're maybe this far apart. But these surf marks are about this far apart. And the squirrel was actually having fun doing the surfing as it was going across. Well, I think it was having fun. It looked like it was enjoying itself. So anyway, fun with squirrels, watching the squirrels play around in the snow. And we're going to finish off this section by talking about man and some of the man footprints. And these are footprints from 3.2 million years ago, found in Africa. So they're from Australopithecus. And what's very critical about these is that they are bipedal footprints. So that clearly whatever these ape-like creatures were doing, they were walking on 2 feet rather than 4 feet. So very, very significant. And these were preserved in lava. And there wasn't just one set of footprints. There were several sets showing that they were walking around as a group. These ones here, the footprints here, from the UK, and Serendipitous found these guys went to do a geophysical survey on the beach, these scientists. And what did they find there? But sets of hundreds of human footprints. And this is what the footprints look like. And these I don't know what these humans were doing. Maybe they were dancing or something, because there's an awful lot of these footprints here. But anyway, they were preserved, and they're about 900,000 years old. So the oldest European footprints. And they're right by a pier up in East Anglia in England. And then I just put in a couple of fun examples as well. So these are hand prints here. They don't actually show up very well, but these are handprints where the indigenous person has put their hand on the rock, and then they blow paint on top of it to leave a handprint surface on there. So we don't know how old they are, but they count as a trace fossil. And then this is one small step for man, so that's from the moon. Not many of those footprints around. And then I just put Jack Nicholson in there because he shares my birthday and my initials. And my love of alcohol. No, I'm just joking. And finally, so I promised this in the abstract that I put together. So we're going to talk about coprolites and wees. So coprolites are fossil poos, and there's a huge variety of fossil poos. And when you see something like this, which is a turtle, which a turtle has squeezed out, it's a pretty obvious that that's some kind of deposit that the turtle has made. But generally speaking, it's a lot harder to identify. This is a dinosaur coprolite. You can't, I mean, it's just like a blob, and they're quite often agatized. So somebody has taken the trouble to split this poo in half to expose the beautiful colors inside, which is something that I don't think happens today with modern ones. But anyway, so this is from back in Jurassic times. So there are lots of different kinds of poop that have been identified. And these ones are from sharks. Sharks often do spiral coprolites as well. But there is only one example so far of a dinosaur weeing trace. And this is the dinosaur weeing trace here. And it's a little bit of a leap of faith. This guy is standing carefully to the side here so he doesn't get his feet wet. But anyway, so this is an enigmatic structure. It's a depression in the sediment, which is hard to explain. And this is where a lot of trace fossil kind of ichnology comes from, is looking at these hard to explain traces. So we can't promise that this is a dinosaur. Urolite is the technical name that they invented to describe this structure, but it's definitely possible. But maybe one day we'll find a dinosaur trace where the dinosaur has actually written his name in the sand, T-Rex written in the sand. So I'm hoping that will happen one day. Okay, so I'm just going to conclude by saying, clearly the study of neoichnology, the modern traces, is very much alive. And there's some great modern traces for us to look at. And interpreting them is great practice and a great kind of like hint as to what we should be looking at in the fossil record. So I think we should be looking and broadening our scope in the fossil record to look for a much wider variety of trace fossils than we see now. And I think that for everybody, every geologist, but for everybody who's just out there walking, if you see something in the rock that's tough to explain, every chance that it could be something to do with an animal or animal related. And what I'd also like you guys to take away is that if you see an animal doing something funny, anything funny, a deer, a squirrel, a coyote, your partner, just look and see what traces they've left behind, because it might be something that you can then apply in the fossil record. So I'm just going to show you some pictures of animals and we can have a think about what kind of traces they might make as well. So thank you very much.